Hi there guys, and welcome once again to iTTV for this mathematics lesson. And my name is Mr. Joe, your tutor. Alright, so now it's time to take a look at our next chapter, and the title of this chapter is Gradient and Area under a Graph. Alright, now let's take a look at the first aspect in this chapter. Quantity represented by the gradient of a graph. Alright, so now when we actually draw graphs, right, the most common graph that we have come across is actually the straight line graph. And every straight line graph, as we have already learned previously, can be represented by its respective gradient. And the gradient is actually also called the slope of the graph. So take a look at this graph right here. We have three straight lines, as you can see. So the gradient is the slope of a graph. We have the lines y equals to 2x, y equals to x, y equals to half x. And now take a look at this point. The steeper the graph, the greater the gradient. Alright, so the difference between those three straight lines are actually the degree of steepness. As you can see, the graph or the line y equals to 2x is the steepest, right? Followed by y equals to x, and y equals to half x has the least gradient. So as long as your gradient is going to a higher value, it means that the steepness is actually going higher as well. Now, how do we actually calculate gradient? This, guys, is very important because we will be taking a look at a lot of straight lines later on. So let's go back to the basics right now. Alright, for us to calculate gradient, take a look at this. We have a straight line, let's say it is a straight line, and we have 2 points. Alright, so we have the first point on the bottom is actually x1, y1. It can be any coordinates. And the point on the higher level is actually given coordinates x2, y2. And from there, we can actually determine the vertical and horizontal distance between those 2 points. Now, this is what we have learned in the previous year. Gradient of a graph is equals to the vertical distance over the horizontal distance, or equals to y2 minus y1 over x2 minus x1. The gradient or slope of a straight line graph is constant and can be found by taking the coordinates between any 2 points. Alright, so that is what we have learned, especially in the straight line. Remember that chapter? Don't forget that every straight line has a gradient, and a gradient is very special because it tells you the steepness or the slope of the line. Alright, so the steeper the line, the greater the gradient. But now, do you guys know that actually the gradient can represent a certain meaning, especially when it relates to certain types of graphs? So let's take a look at the next point. Gradient of a graph is also equals to rate of change of the quantity on the vertical axis with respect to the quantity on the horizontal axis. So now in certain types of graphs, when we apply it to our daily lives, take distance or speed or time for example, when we actually draw these graphs and a straight line actually has been obtained, the gradient will actually carry a certain meaning. And the meaning is always the rate of change of the quantity on the vertical axis with respect to the quantity on the horizontal axis. Alright, now let's take a look at these three graphs again that we have seen earlier on. Now we start with the line with the least gradient, as we've seen earlier, y equals to half x. Now, what is the gradient? We can actually find it by taking any 2 points and actually determining the vertical distance, as you can see, and divide it with the horizontal distance. Now, let's go to a line with a higher gradient, and hence y equals to x. Same thing, alright? As long as you want to calculate the gradient, just pick any 2 points and draw a right angle triangle and determine the vertical distance, which is the straight distance, alright? Or the height between the 2 points, and as well as the horizontal distance. Now, this is the graph with the highest gradient out of the three, y equals to 2x, and same thing. All right, notice that the vertical distance is the highest compared, all right, with the two other graphs. And also you must determine the horizontal distance before you can actually calculate the gradient. From these graphs, observe that the changes in quantity y, all right, which is, all right, the vertical distance is greater when the slope gets steeper. All right, so that is something that you guys must always notice when you come across straight lines, because although they are all straight lines, but their position and their gradients or their steepness will actually tell you a lot of things, all right, of the quantities involved. So just remember the gradient now. When we apply it to certain cases, it means the rate of change of y with respect to x. All right, now let's take a look at this example. The graph below represents the volume of water in a tank for a particular day. What is the quantity represented by the gradient of the graph? Alright guys, take a look at this question again. You must highlight or underline the words in the question when you see questions like this. Quantity represented by the gradient. It is actually asking you, when you actually find the gradient of this graph, what meaning does it carry? So now let's take a look at this graph. Alright, so it is a graph of the volume of water against time in hours. Alright, now let's take a look at this. So the vertical axis or the y-axis is volume of water, right? And the unit is in meters cubed. Now the horizontal axis or the x-axis represents time with unit hours. The gradient is equals to the change in volume of water over the change in time, and also equals to m cubed over h in terms of units. So what can we actually say about this gradient is it means that it is the rate of water storage. Or if you want to put it in long words, it is actually the rate of change of the volume of water with respect to time. But think logically, it means rate of water storage. Alright, means the more or the longer time you just let it go, you know that what you can do is store more water. So the unit involved is meters cubed per hour. Alright, so we have an example right here. Now let's take a look at this example and let me just show you, alright, what to do when we represent the gradient, alright, and try to get the meaning of it. Now let's take a look at this example. State the quantity represented by the gradient of each of the following graphs. Alright, we'll be taking a look at a couple of graphs here. What we are going to do is to represent the gradient, alright, and what quantity represents the gradient. Now let's take a look at this first table. We have two quantities, time in hours and distance in kilometers. Alright, so the time is from 1 to 5 hours, and you can see that the distance increases also from 60 kilometers all the way to 300 kilometers. Now, when you draw the graph, you will get a straight line graph like you see right here. Alright, the question is, when we calculate the gradient of this straight line graph, what quantity is it actually? Alright, so let me just show you on the board. What do you do when you come across questions like this? Alright, so take a look at this graph right now. So it is, alright, a straight line graph, alright, for distance against time. Now what you're going to do is notice that once the time increases, right, you will actually cover more distance, alright. So what we're going to do is now represent the gradient. What quantity represents the gradient? So all you're going to do is remember the gradient represents the rate of change of the quantity on the vertical axis with respect to the quantity on the horizontal axis. Alright, so on the vertical axis, alright, or y-axis, what we have is distance, right, in kilometers. And what quantity is on the horizontal axis is actually time. And the unit, hours, right? So now remember the gradient. What is the gradient? The gradient of this graph can be represented by, remember the definition, rate of change must always be there. So it is the rate of change, all right, of the quantity on the vertical. Now we know it is distance, so we write it right there, of distance with respect to the quantity on the horizontal axis, which we know now as time. So rate of change of distance with respect to time. Okay, so remember that this is the correct definition of the gradient of any graph. But now we have actually one short word to represent this whole thing. Remember that actually the rate of change of distance with respect to time is actually the speed, all right, of the object that is traveling. All right, so this is a very special graph. We'll be taking a look at this graph again because it is distance against time. And the distance time graph is actually very important in our daily lives. Alright guys, so that is a very important graph that we have just seen, alright? But just put it aside for a moment. Let's take a look at the next example, because what we are going to do right now is the same thing, which is stating the quantity represented by the gradient, which means when you have a straight line graph and the gradient is calculated, what value does it represent? It's no longer just a value because it represents the rate of change, right, between two quantities. Now, state the quantity represented by the gradient of each of the following graphs. Alright, so now let's take a look at the second one right here. Two quantities involved are time in seconds and speed, meters, second. Alright, so we have the two quantities and the values are there. When you actually draw the graphs, it will look like this. Alright, so the two quantities are there, straight line graph obtained when you plot the points. But now, what we're going to do is represent, all right, the gradient with a certain quantity. So what are the quantities involved again? On the vertical axis or y-axis, we have the speed, all right, which has a unit of meter per second. And on the horizontal axis or the x-axis, the unit is time. The gradient is equals to change in speed over change in time, all right, or meters per second over second. Now, it is also called the rate of change of speed with respect to time, because speed is on the y-axis and time is on the x-axis. But now we have also just one word to represent that whole phrase, and that is called acceleration, which has a unit of meter second square. Alright, okay, so we have learned how to actually state the quantity that represents the gradient of a graph. Just remember, any graph that you see, alright, when it has two quantities which are known, distance, speed, time, and all that, the gradient represents the rate of change. Remember that word, is a key word. Rate of change of the quantity on the y, whatever that is, with respect to quantity on the x-axis, whatever that is. Alright, so now we have learned how to identify the quantity that represents the gradient. Let's move on to the next part, alright, which is taking a look at the gradient of a distance time graph. So take a look at this graph. Alright, it is a distance time graph, distance or S, alright, in kilometers on the y-axis and time in minutes on the x-axis. The distance time graph shows the journey of an express bus along a highway from a point 20 kilometers from the bus station. Alright, so this is what graph is it exactly. Now, how do we actually find the gradient of a distance time graph? Let's look through the methods, alright. In method 1, firstly, select any two suitable points on a straight line. Alright, so this is what you're going to do. Take a look at this graph. Alright, so select any 2 points, random points, alright, on the straight line. Next, construct a right angled triangle. There, like this, alright. So from the 2 points, draw a right angled triangle, and from there, notice the vertical distance and the horizontal distance. Next, gradient is equals to vertical distance over horizontal distance, right? So it is also equals to the distance over time, because that are the units expected, which is equals to distance over time, because distance and time other quantities respectively. So 400 minus 100 meters over 70 minus 10 seconds. And we get the gradient is actually 5 meters per second. And the gradient represents speed. Remember that, because the rate of change of distance with respect to time is actually speed. So one thing to remember is the gradient of a distance time graph is actually speed. Okay, that is the first method, using the vertical distance over the horizontal distance, and that is called the ratio, alright, of the two distances. Now, in method 2, to find the gradient, we can also do and find the steps. Firstly, select any two suitable points on the straight line. Same first step, like this, alright? So choose any 2 points. Second step, slightly different. Name them as A, x1, y1, and B, x2, y2, alright? So just assign to them a name. So from those 2 points that we have chosen, let one of them be A, alright? And if I'm referring to the graph, A happens to have a coordinate of 10, 100. B happens to have a coordinate of 70, 400. Third step, use the formula gradient is equals to y2 minus y1 over x2 minus x1. So get the vertical distance, 400 minus 100 meters over 70 minus 10 seconds, which is 300 meters over 60 seconds, which gives you the same value of 5 meters per second. And again, guys, don't forget the gradient of a distance time graph is a speed, so you must include the speed unit, which is meters per second. Alright, so that is very important, one thing to remember. Okay, so how do you find the gradient of a straight line? That's how you actually found it. Alright, when you learn the straight line itself, you can either use method 1 or method 2. But the most important thing right now is to recognize that in this kind of graph, which is the distance time graph, the gradient is the speed. Alright, so now let's go on to the next part. Calculating the speed from the distance time graph. Alright, so in other words, calculating the gradient from the distance time graph. Alright, now let's take a look at this example right here. Take a look at this graph. Alright, the distance time graph shows the movement of a car from town X. It is heading towards town Y. It travels back to town X. The distance time graph shows the whole journey of the car. Calculate the speed in kilometers per hour of the car for the journey A from 700 hours to 1100 hours, B from 1100 hours to 1300 hours, and C from 1300 hours to 1500 hours. Now let me just show you and explain to you the distance time graph. Alright guys, the distance time graph is actually a very important graph. Now we know that this is actually a distance time graph. Take a look. So distance in kilometers, time in hours. But one thing that you have to make sure is look at the units. This time is actually representing real time. 700 hours means 7 in the morning, right? 8 in the morning, all the way until 1500 hours, which is 3, alright, PM, 3 past noon. Okay, so what we have here is this travel, okay, by this object, and it is starting from right here. Take a look now. We are actually measuring, alright, the distance, alright, according to time from this point all the way up here, alright, and then it doesn't change distance and then it goes back down. So what we're gonna do is first of all find the speed from 700 hours to 1100 hours. So remember this, guys. Alright, what we're actually gonna do is find out the gradient of this straight line from this point to this point. So I'm going to actually draw dotted lines, alright, so that you can see the right angle triangle form. Alright, so why do we actually draw a dotted line right here? Because we are asked to find the gradient from 7 o'clock in the morning to 11 o'clock. Alright, so this is the right angle triangle that is formed. So this, alright, car or whatsoever will have a speed. And what is the speed? It is the gradient. All right, so what is the gradient? Let's find out. We can straight away use, all right, the ratio. And what is the vertical distance? Check. It is 100 kilometers, right? What is the horizontal distance? All right, so it is actually 7 to 8, 8 to 9, 9 to 10, 10 to 11. So it is actually 4 hours. Don't forget, it is hours, all right, because we are in real time. So we have a speed of 25 kilometers per hour. And that is the speed taken to travel from this point to this point. Okay, now let's go on to the next one, all right, which is actually finding the speed from 11 o'clock to 1 o'clock or 1300 hours. So what you're going to do is realize that that is the part when the line is actually parallel to the time axis, okay? So let me just draw dotted lines right here. Okay, so what is the speed that is taken when this object travels from this point to this point? Okay, same thing. What is actually speed in a distance time graph? It is the gradient. Okay, and the gradient, same thing, determine the vertical distance. All right, is there any vertical distance? No, right? Because both these points lie on the same line. There is no, so it is 0. What about the horizontal distance? 2 hours, right? So actually, there is no speed. Why? Because when the object comes right here, it is actually resting. That is why the distance remains 100 kilometers from its starting point. All right, and lastly, all right, the speed or the gradient, all right, for this car, all right, from 1 o'clock to 3 o'clock, all right, or from 1300 to 1500 hours is actually same thing goes. Remember, vertical distance, all right, because this is the right angle triangle now. So I want to find the gradient of this line, 100 kilometers over, what is the time taken? 2 hours from 3 p.m. to from 1 p.m. to 3 p.m. So that is actually 2 hours, and we have a speed of 50 kilometers per hour. So remember to find the gradient, all right, it is actually representing the speed of the object in a distance time graph. All right, now let's take a look at the next graph, all right? Let's read carefully this question. The diagram shows the distance time graph of Mandy from a house to school passing by a traffic light when traveling in a car. All right, so remember when you come across questions like that, try to just imagine the situation. So there's this girl right here, all right, and she's traveling to school, but on the way she passes a traffic light. So this is the graph that represents Mandy's journey. All right, so we'll look at that later on. Calculate A, the distance in kilometers between the traffic light and Mandy's school. B, the speed in the first 5 minutes. C, the speed in the last 20 minutes. All right, now let me just do this together with you and let me just explain to you again, because this is the first type of graph in this chapter, the distance time graph. Okay, so this is the graph that we have seen right now that represents Mandy's journey, all right? So it says that she goes, all right, from a house to a school passing by a traffic light. So where do you think are the 3 positions? This definitely will be her home, all right? So this will be Mandy's home right here. Why? Okay, because that is where she starts her journey. So that distance is calculated from her home. So 0 kilometers, all right, because that is the reference point. Now, notice that she travels right now, all right, to a first point right here. So this line is actually now representing the distance, all right, and the time needed to arrive at the middle point, which is the traffic light, right? So this will be the traffic light. Okay, so we need to analyze the graph, remember, and then obviously after the traffic light she goes, all right, and covers some distance to her school. Okay, so these are three important landmarks. All right, why are the lines slightly different? Because of different speeds. All right, from her home to the traffic light, notice that the gradient is steeper than from the traffic light to the school. This means that she actually drives, or not her, all right, her parents drive her, all right, faster, all right, from this point, home, to the traffic light, and then slightly slower because a least or lesser gradient from the traffic light to school. All right, so always analyze. So when you see a positive gradient, what you're actually doing is remember that you are actually moving away from your starting point. All right, so that is how you analyze. Now let us find out and answer those questions. Firstly, distance between traffic light and school. All right, so let's look. What is the distance between the traffic light and the school? And when you talk about distance, it is actually just the vertical distance. So this and this, all right, although it's a diagonal line, the vertical distance is just 25 minus 20. So it is just 5 kilometers. Okay, so that is the distance between, all right, the traffic light and the school. Now, secondly, the speed in the first 5 minutes, all right, you must be very sensitive, guys, because the speed, the first 5 minutes of travel is here. The speed of a distance time graph refers to the gradient. So you must actually find the gradient of this straight line. So what is it? So remember that the gradient can be found using any of those two methods. I'm going to use vertical distance over horizontal. Okay, so this is the right angle triangle. Vertical distance is 20 kilometers. Horizontal distance 5 minutes. So the speed is actually 4 kilometers per minute. Where is that? Right here. Okay, now let's go on to the next part, which is the speed in the last 20 minutes. All right, it is from 5 to 25. So this is the last 20 minutes. This is the first 5 minutes. So same thing, we want to find out what is the speed. So calculate the gradient. What is the vertical distance? All right, check carefully. This is the one. All right, the vertical distance is just right here. So it is 25 minus 20, which gives us 5. All right, over 20 minutes. Okay, because this is the time taken. So simplified is 1 over 4 or 0.25 kilometers per minute. So guys, remember that what you have here actually is the gradient, which represents speed in a distance time graph. Alright, now let's take a look at the next part here, which is D. The average speed for the whole journey of 25 minutes. Alright, so because she travels at different speeds, we need to find the average speed. So let us find the average speed of Mandy's journey again. Alright, so what is the formula for average speed? Okay, so the average speed is actually equivalent to the total distance over the total time taken. Alright, so this is very important. This is how you find the average speed. So total distance over total time. Let's go back to the graph. Alright, so what is the total distance taken by Mandy? Alright, she takes 20 km from the home to the traffic light and another 5 kilometers from traffic light to school. So the total distance is actually 25 kilometers. What about total time? 25 minutes. So let's put it right here. So 25 kilometers divided by 25 minutes will give us an average of 1 kilometer per minute. Alright, so now it's your turn to try out one question by yourself. Alright, just remember to put all that you have learned into application. Take a look at this question. The graph JKLM represents the journey of a lorry and the graph JLN represents the journey of a car. Both vehicles depart from Kuala Lumpur at the same time and travel along the same road. There. This is actually the graph that you get, but just bear in mind that we have two graphs on the same axis right now. A, state a period of time during which the lorry is stationary. B, calculate the average speed in kilometers per hour of the lorry during the period of 8 hours. C, at a specific time during the journey, both vehicles are at the same location L. State the distance firstly in kilometers in between location L and Kuala Lumpur. 2. State the time in hours taken by the car to reach location L from Kuala Lumpur. And D. Calculate the average speed in kilometers per hour of the car during the period of 8 hours. Alright, so this is a pretty long question. Alright, it always comes out in the long question part, but just analyze it step by step. So why don't you guys actually try this out by yourselves? Okay, so now take a look again. Let me just run you briefly through, alright, this graph. Take a look at JKLM. According to the question, this is the route, okay, or the travel pattern, alright, of the lorry, JKLM. GLN, more direct. It is a straight line, alright, that goes straight up until N, alright, represents, alright, the car's journey. Alright, now let's answer the question directly, alright. A, state the period of time during which the lorry is stationary. Now, look at the lorry. The stationary part is from point K to point L. It is from the time of 3 hours to 5 hours. Alright, so this is the period of time where the lorry does not move. It is resting. Alright, 3 hours to 5 hours, alright, from the start. So altogether, it is actually 2 hours, alright, from the starting point. Now, let's take a look at B. Calculate the average speed of the lorry during the period of 8 hours. Okay, so average speed again for the period of 8 hours. So it is the whole journey but of the lorry, alright? So what is average speed? Again, it is total distance over total time. So let's take a look at what is the total distance traveled by the lorry. Alright, it is from here to here, 300 kilometers, doesn't move. And from here to here is another, alright, 340 kilometers. So a total of 640 kilometers. And the time taken is actually 8 hours. Alright, so the average speed taken by this lorry, alright, is actually 80 kilometers per hour. Okay, so remember to analyze. Don't look at the cars one yet because we are just focusing on the lorry. Okay, for C, what we're going to do is firstly state the distance between location L and Kuala Lumpur. Alright, so where is Kuala Lumpur? That is where they started, alright? And L is right here. So what is the distance between Kuala Lumpur and L? Just check, alright, the distance, alright, axis. It is, because L is on the same level as 300, it is actually just 300 kilometers. Okay, and what about C2? C2 is finding out, state the time taken by car to reach location L from Kuala Lumpur. Alright, so state the time. So now the car, just take a look, J to L. Okay, so what time taken? Just read from the axis, 5 hours. Alright, and lastly, alright, finding the average speed of the car. So again, guys, remember, average speed is always total distance over total time. Okay, look at the car's one right here. Okay, so this is the line of the car. Alright, so total distance, alright, traveled by the car is actually 480 kilometers. Total time taken, 8 hours. So we have the average speed of the car as 60 kilometers per hour. So alright guys, let's come to a quick review of what we have learned in this lesson. Alright, so a few important points to note. Firstly, state the quantity represented by the gradient of a graph. That is what we have learned in the very first part. Alright, secondly, draw the distance time graph. Alright, so we have also learned how to identify a distance time graph. Thirdly, calculate the gradient of a distance time graph. Fourthly, understand that A, speed is equals to gradient of a distance time graph. B, the horizontal part of a distance time graph indicates that a particle is at rest or stationary. C, average speed is equals to total distance traveled over total time taken. And lastly, solve problems involving distance time graph. So we have also learned how to solve little questions involving the distance time graph. So alright guys, that's all we have for you right here for this lesson. Remember to actually study the properties of a distance time graph again. I'll see you in the next lesson for more of gradient and area under graphs. See you in the next lesson.